learners, thank you for tuning in again for our math literacy class on bar and number scales. Did you know that we use scales to reduce or enlarge sizes of objects? For an example, we know the actual size of a car, but when we see it on a picture, on a paper, we can see that the size has actually been reduced. That is where scales come in. At the end of this lesson, you should be able to express scales in appropriate forms. You should be able to read information from scales, be able to explain advantages and disadvantages of a bar and a number scales, be able to calculate actual distances. The conceptual mind map that we're going to be using in this particular lesson will be based on scales, number scale, as well as a bar scale. You should know by now how to work with ratios and how to measure length and distance. Let's express the following units in unit ratios. What does a unit ratio mean? It means that the answer that you get should give you 1:2 something. So we are expressing it in a unit ratio that 1:2 something. So if we are to express number A, 2:4 as a unit ratio, what do? You first have to check whether does the number on our left-hand side go into the number on our right-hand side. If it does, then you can divide by the very same number and check whether does it leave your answer in the form of 1:2 something. Let's do that. When we say 2 divided by 2, what do we get? We get 1:2 something. Then we say 4 divided by 2. So whatever we do on our left-hand side, we must also do on our right. So the very same number that we divided with on our left-hand side, we should also divide with on our right-hand side. So we're going to have what is 4 divided by 2? It gives us 2. So it means this ratio expressed in a unit ratio or a unit form is 1:2. Then we go to the next one. We also check, does 25 go into 75? Yes, it does. Then we can check whether when we divide by 25, what are we left with on our right-hand side? So we say 25 divided by 25 will give us 1:2. What is 75 divided by 25? 25 goes 3 times into 75 because it's 25, 50, then 75. So it's 3. Then it means the expressed unit ratio is 1:3. Then we go to 250 is to 1,000. So does 250 go into 1,000? Yes, it basically does. So when we divide both sides by 250, then we say on our left-hand side we'll remain with 1 because 250 divided by 250 is 1. Then what is 1,000 divided by 250? We've got 250, 500, 750, then it's 1,000. So it means it goes 4 times. So some of these calculations, they generally don't need a calculator. Then we go to the next one, D, which is 14:18. Then we can check, does 14 go into 80? Generally would think that it doesn't go, but there is a number that can go both in both numbers. But that is not the intention of this exercise. The intention is to leave our answer in a unit ratio. So it doesn't matter whether 14 goes into 80 without leaving a remainder or not. You just have to divide by 14 so that you can be left with 1 on your left-hand side. So we divide by 14 both sides. Then what is 14 divided by 14? It's a 1. Then what is 80 divided? Then now you need your calculator. Let's punch 80 divided by 14. We get, it's actually 40/7. It's 40/7. You can leave it as a decimal number, which will be 1:2. What is 40/7? It's 5.71. So that is your unit ratio. Then we do the last one, 175 is to 125. 175, we can already see that it's bigger than 125, but the intention is to leave our left-hand side being 1. So we divide both sides by 175, and then even 125 divided by 175. So 175 divided by 175 gives us 1. What is 125 divided by 175? Let's do it on our calculators. 175, it gives us 5/7, which you can leave as a decimal number. Then it says 5/7 is 0.71. Then question 2 says, if the distance between 2 towns is 43 kilometers, how far apart are they in centimeters? Now we have to convert from kilometers to centimeters. Remember the method that we once did that says, Keke hates doing math during cold months. So where are we moving from? Kilometers to centimeters. So what do? We multiply by the number of times we'll be moving. So you put a 1 on the kilometer and it zeros up until where you're going. So it's actually 100,000. So we're going to say 43 multiplied by 100,000. So what is 43 multiplied by 100,000? It gives us 430,000. Is it 430,000 or 4 million? Let's check. 43 multiplied by 100,000. It gives us 4,300,000. 4,300,000. Then we go to the next one. A car is parked 670 millimeters from the pavement. How far is the car from the pavement in meters? So you're converting from millimeter to meter. We check millimeter to meter. So you put a 1 and zeros up until where you're going, but we are dividing. So it means we're going to say 670 divided by 1,000. What is 670 divided by 1,000? 670. Let's do it together. Divided by 1,000, it gives us 0.67 meters. Let's not forget to put in the new units, which is centimeters, and here it's meters. Okay, then the next question, calculate the total distance of a snail. Calculate the total distance a snail moved in a day. If it moved 62 centimeters, then another 123 millimeter, then finally 0.5 meter. Give your answer in centimeters. So it means we must convert all our units to centimeters. The first one that we have is 62 centimeters. There's no need to convert that. Then we have to convert millimeters to centimeter. We said KK hates doing math during cold months. So we are moving from millimeter to centimeter. It means we divide by 10. So what is 123 millimeter divided by 10? It gives us 12,3 centimeters. Then the last one, we have to convert the 0.54 meter to centimeters. So meter to centimeter, we're moving from M to C. Then it's going to be a 1 and 2 zeros. Then we are multiplying. So what is 0.54 times 100? 0.54 times 100, it gives us 54 centimeters. So we multiply by 100. Let's erase that. Then it gives us 54 centimeters. Then we add everything together because they wanted the total distance. So we're going to say 62 centimeter plus 12.3 centimeters plus 54 centimeters. What total centimeters are we getting? So we say 62 plus 12.3 plus 54. It gives us 128.3 centimeters. So this is the total distance that the snail moved in that particular day. The new words and language that we'll be focusing on, the first one is a scale drawing. A scale drawing is a drawing or a map which represents the size of the picture on the drawing in relation to its actual size. So if this was a table of some sort, the actual sizes will be 8 meter and 3 meter, which will be reduced because it has to be drawn on a piece of paper. It will be reduced by a scale of 1:30. It means it is 30 whatever units less than its actual size. Then we go to the scale factor, the factor by which the size of the real object is either reduced or enlarged. For an example, the bus is drawn 100 times smaller than its actual size. Obviously, we know that we cannot draw a bus with its actual size on a piece of paper, so we have to reduce this. So that is the scale factor. Then dimensions. The dimensions are the measurements of an object which describes its size in terms of the length, the width, the breadth, and the height. For an example, the dimensions of an aeroplane, it has a length of 30 meters and it also has a width of 28 meters. Numeric scale is a scale that is written in a form of a unit ratio format. So unit ratio format, it's written in the form of a ratio, but it should be a unit which is 1:5. Normally we represent it as a unit ratio where it's 1:something all the time. Then we have a bar scale. A bar scale is a graphical representation of a scale by means of lines with ruler markings and units that are proportional to the scale. So we've got a scale, but it's a picture scale in a way, and then it gives us the relation of the bar, which should be measured in relation to its actual size, which are these units that are given to us there. So let's take a quick break, and then we'll continue afterwards. Welcome back, learners. I hope you had a nice quick rest. And now let's continue to scales. A scale is a ratio between the distance on paper and the actual distance in reality. Dimensions are used to describe the size and the shape of an object. And it describes them in terms of the length and the width or breadth of the object if that dimensional object is a 2D figure. Then if ever it's a three-dimensional figure, then it will describe the sizes and the shape in terms of the length, the width or breadth, and also the height. This is an example of the dimensions with the different two figures. In a two-dimensional figure, we'll only have the length and the width or breadth. And then in a three-dimensional figure, we'll have the height, the length, the width as well. Then a scale drawing is a representation of an object as a real object in a different size. So whenever you do a scale drawing, you'll definitely use the very same object that you are scaling down, but it will just be in a different size. For an example, when you draw a car on a piece of paper, it's still the very same car, but then the size has been reduced so that it can fit on the drawing paper. Each dimension is either enlarged or reduced by a certain ratio called a scale factor. You can either reduce the size by 30 times less or enlarge it by 30 times more. So when are we enlarging and when are we reducing? When we are enlarging, this is basically when, let's say you have to draw an ant. An ant is a very small thing. It's a very small animal. So you have to put it on a piece of paper. It means you have to enlarge its size. But when you're drawing something big like a car is very big, so you have to reduce its size so that it can fit on a drawing paper. We have an example there. The length of a crocodile below is 400 centimeters in reality. 400 centimeters in reality. So if you can do a quick quick division there to convert it to meters, it's actually 4 meters in reality. Then if we were to draw this crocodile, it means that we'll have to reduce its real size using a scale factor, because now we cannot fit 4 meters on a piece of paper, so we have to reduce the size. The picture below is drawn 100 times less than its actual size. So we've reduced the 400 centimeters by 100 times so that it can fit on the drawing paper. So that is the scale factor. The length of a crocodile is still 400 centimeters. The picture below is drawn 100 times less than its actual size. Now, identify the scale factor used to reduce the actual size of this crocodile. The scale factor is 100. So it means we reduced it by 100 times. So if we were to represent this as a number scale, we'd actually say it's 1:100, showing that 1 unit on the map will represent 100 units in reality. What is the drawn length now of this crocodile? If its actual size is 400 centimeters and we've reduced it by 100 times, it means we have to divide by what? By 100. So it means the drawn length will be 4 centimeters. So it means when we took a ruler and we drew this crocodile, we used the dimensions of 4 centimeters. Okay, then now we get to the number scale. A number scale is a scale expressed as a ratio, as a unit ratio, which is 1:400. That is an example, or 1:2 something, but it should always be 1 on the left-hand side and another value on the right-hand side, which means that map is to reality. It means that this one will represent what is on the map and the 400 will represent what is in reality. Where 1 unit on the map represents 400 units in reality, and 400 becomes our scale factor. Why is it a scale factor? Because it is the amount by which we have either reduced or enlarged our drawing. Advantages of a number scale. The ratios have no units, so you're not working with any specific units. You will be directed by the question how you should leave your units at the end after calculating. Therefore, the distance on the map and in reality can be explained using any desired unit. So if you are given a scale of 1:400, if you want to explain this scale, you can choose to say 1 centimeter on the map will represent 400 centimeters in reality, or you can say 1 meter on the map will represent 400 meters in reality. So you can use your own desired units to express a number scale because it does not include any units of some sort. The disadvantage now with a number scale is that when the map on paper or the picture or an object on paper is resized, it means when we have either reduced the drawing paper or reduced the drawing on that drawing paper, then the scale becomes invalid. Remember, initially when you draw maybe a crocodile, we drew it reducing it by 100 times. Then if we decide now that we want to resize the paper again, let's say when we reduce it initially, we printed it on an A4 paper. Now we want to reduce it even further because we want maybe to put it 2-in-1 when we're doing printing. We want to put it on an A5 instead of an A4. Then we've reduced the picture of that drawing again, but it still maintains the same scale. Then it means that scale now no longer is valid. Question 1 says, convert the following verbal scales to a number scale and write it in unit form. Remember, when you write the scale in unit form, it means it should be 1:2 something. So that's how they want us to represent these verbal scales. So let's start with A. A says 1 centimeter on the map. Remember, when we write number scale is represented as map is to reality. So what does this mean? This means whatever we have that says on the map should be on our left-hand side, and what it says is in reality should be on our right-hand side. So the question says 1 centimeter on the map. So it means we have 1 centimeter on our left-hand side, represents 150 meters. So it's 150 meters in reality. Now the question further says that we must write it in unit form. So when we write it in unit form, then it means we must have 1 on our left hand side and is 2 whatever it is on our right hand side. So having 1 on our left hand side, it means we must divide both sides by what is on our left hand side. But unfortunately we can't because the units are not the same. We must start by converting. How do we convert? We use the KK method. We say KK hates doing business during cold months, whereby the business will stand up for our meters. So we have to convert either from centimeter to meter or from meter to centimeters. It is easier to convert where you are multiplying. So let's convert from meters to centimeters. From meters, we put a 1. We are converting to centimeter. It's zeros up until where we end. Then we multiply. So it means we'll multiply 150 by 100. Then we have 1 centimeter is 2. 150 times 100, what does it give us? It will give us 15,000 centimeters. Now our units are the same, but remember a scale does not have units at the end. So we divide both sides by 1 centimeter. So we divide by 1 centimeter, divide by 1 centimeter. This means all of this will give us 1 on our left hand side, and on our right hand side we'll have 115,000. So this is the scale written in unit form. Then B says 10 millimeters on the map. So it's 10 millimeters is to represent 100 meters in reality. We have 100 meters in reality. We have to do the same thing that we did in A, whereby we have to write it in unit form, which has to be 1:2 something. So we need to divide both sides by 10 millimeters, but unfortunately we can't because the units are not the same. So let's convert our meters to millimeters. From meter to millimeter, we'll have 100, we'll have a 1 and zeros up until where we end, then we are multiplying. So we'll multiply by 1,000. Then we'll still have 10 millimeters on our left-hand side. Then what is 100 multiplied by 1,000? It will give us 100,000. So we have 100,000 millimeters. Now we've got all the units being the same, so we have to remain with 1 on our left-hand side because it's unit form. So we divide both sides by 10 millimeters, even on our right-hand side by 10 millimeters. So 10 millimeters divided by 10 millimeters will give us 1 is to what is 100,000 millimeter divided by 10 millimeter. So a 10 will go just once into this. It will cancel just 1 0 in this 100,000. So we are left with 10,000. So it's going to be 10,000. So the scale is 1:10,000. Then we move on to the next question. Question 2, explain the following scale. So the moment it says explain the following scale, it means you must now write down the unit scale as a verbal scale. So 1:150,000. So it means 1 unit It means 1 unit on the map represents 150,000 units in reality. So that's how you explain a unit scale. Then we go to the next one. B says 2 units on the map will represent 300 units in reality. But remember, a number scale cannot have a number that is more than 1 on the left-hand side. So we have to simplify it. So how do we simplify 2 is to 300? We divide both sides by a number that will give us a 1. So it means 2 should be divided by 2. Even on our right-hand side, we divide by 2. 2 divided by 2 will give us 1 is to 300 divided by 2 is to 150. Then we explain it. Then we'll say 1 unit on the map represents 150 units in reality. Then let's move on to the next one. To determine the actual distance or the actual length, we use the following general formula. We say actual dimensions are equal to the map dimensions, which are the measured dimensions, multiplied by the scale factor, which is how have you reduced your scale width. So now we are given a kitchen plan and it's drawn to a scale of 1:100. It means the scale factor is 100. They say now the question, calculate the actual length of this kitchen. Actual length, what is the length of the kitchen? It's always the longest side, so it's 9 centimeters. We are not given by which unit should we leave our answer to, so we'll just say 9 centimeters is equals to, because actual dimensions is equal to, let's maybe write it, actual dimensions are abbreviated to AD. Oh, we are looking for the length, so we can say AL, which is actual length, equals to the map distance, which is the 9 centimeter. We multiply it by the scale factor, which is the 100. So what is 9 times 100? It gives us 900 centimeters. So this is the actual dimension, the actual length of this kitchen. B says a kitchen plan is also drawn at a scale of 1:100. Calculate the actual dimensions of the kitchen in meters. Now we have to calculate it in meters. We are given the direction. So the actual dimensions now, it means we'll have to take the length and the width. So the length, will say actual length is equals to the map length, which is the measured one, which is 9 centimeter. Multiply by 100, it gives us 900 centimeters. So we have to convert from centimeter to meter. We divide by 100, which gives us 9 meters. So this is the actual dimension, the actual length of the kitchen. Then we have to do the actual width now. Actual width, it's 7 centimeters. We multiply by the scale factor, which is 100. What is 7 times 100? It gives us 700 centimeters. We are converting it to meters, so we divide by 100. It gives us 7 meters. Let's take a break and then we'll continue afterwards.